Welcome back everyone. Today we have a truly exciting episode. We're going to talk about my new application and how you can use it to control and update your Nerf gun. Which this is a work of Swordfish. I use the work of Swordfish because it's far easier than anything else, but this will work in a Stryfe, RS, Dominator and whatnot. So this is where I am right now. This is it's a two-part trigger. So this does automatic, this does single or burst, and this currently is in what I now call Jangular mode, which is the typical rev mode, which is not how I use it. But I understand why you'd want that to reduce the delay, because you do have to wait for the wheels to spin up. So if you've pre-revved them, then the system doesn't need to wait for that. It can just fire them straight away. And also you can suppress the enemy with this button. Most people know that when they hear flywheels spinning, it's time to duck. So you can save a lot of ammo by just revving at people. However, that's not how I use it. I use it in single trigger mode, although I have two triggers. But that's how it works. So single trigger. Oh yes, I have a little LED. And switch this, which the Swordfish has a little switch on here, and I've kind of got this working. Well, I do actually have it working for the little switch on the outside, but obviously it needs to be over that way, but whatever. Now it's going to do double shots, and then all the way back for auto. And like I said, rev. And this one has a trim pot on the back, so you can adjust the speed. This doesn't have an ROF pot, but you can have an ROF pot if you want. There are many options which I have added in the code for all of you guys to use, and it's up to you to use it however you want. I've just done a whole bunch of options, and you guys will hopefully have fun using it. So it is designed to make your life simple, because normally you'd have to program and do Arduino and blah 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 and flash it. And once I started getting a real complicated system going on, there was heaps of options and it was going to be too hard to understand. So let's connect it up to the machine. So you obviously need to download this application, and this is now used for pretty much all your wiring and everything you want to know about everything. So you start off by connecting to it. Now the first thing you would normally do is you would normally have a blank Arduino that needs to be flashed. Before I do any of the wiring, I would recommend that you flash it with at least the default settings, then wire it up and come back. So how you do that now is you do not need the Arduino IDE. You select the COM port, which I know to be that, and you click this button here, and it should go away and download. You can see the serial things flashing down here. It's now writing the firmware to the Arduino with default settings, and hopefully that will work. It seems to think it worked. That sounds like it worked to me. Yes, it did. So now you need to read the settings back off the Arduino. Then you can deploy default settings for stage 1 and stage 3. Stage 1 is without this. It's basically your classical RP, pretty much just your rev trigger spin motors. Now I should have mentioned, and I forgot, all of this stuff that you can do here is available for brushed and brushless blasters. So you don't have to have brushless, although you should all be running brushless, not brushed stuff these days. But you can do it on brushed and brushless. So stage 1 is pretty much just motors. This does support up to 4 stages in brushed and brushless without the pusher control. So you can have a basic, and that's what I consider stage 1. Stage 2 is actually with like a brushed or brushless, basically stage 1, but with a pusher that's not controlled by my Arduino. So that would be like if you buy the Worker Swordfish with the default system, it would be a stage 2, and a stage 3 is when you connect it all up to the Arduino. As far as wiring goes, to some degree I think this is actually easier than wiring it up with the default worker style system, because you pretty much wire all the wires back to the Arduino, which is simpler than trying to get them in their funny little configuration, which in the end, I personally gave up trying to do that, and I just found my own wiring diagram to do it than try and use yours. But anyway, so basic settings. We have brushed or brushless. If you change between brushed or brushless, please restart the Arduino after that. That's quite a significant change, as you can imagine. If you run the Arduino setup for in brushless mode, but with brushed motor / MOSFETs, you could be in a bad situation. Doing the other way around doesn't seem to actually matter, other than the fact that it obviously doesn't work. So you can select the battery. This is a 4S. It's obviously brushless. You can select your motor KVs for all the stages. This is obviously just a single stage, so only select that. Now, for brushed people, you can actually work out what the KV roughly is. If you take the free RPM and divide it by the voltage to achieve that, that will give you the KV, so you can put that in here, and that affects things later on. You do have basic things here, which are maximum RPM limits. So you can now define what the maximum limit of the RPM knob is over here, and obviously the blaster. And there's also a minimum, because because you want to have a minimum value on the knob, so you can do the minimum there. And you can then have this real-time estimator, which estimates the RPM as I turn it, so I'm turning it. And that gives you a throttle percent of 80%, which is consistent with the limit we've set of 80, obviously over here. The knob's all the way up. And that gives us a theoretical max FPS of 232. Now, that is based on a whole bunch of assumptions, so it's not accurate, especially at high RPM, but at the lower RPMs it's surprisingly accurate. I mean, it's based on how charged the battery is. It's assuming that you're using my 3D printed wheels, and it's also assuming that you don't get any slip. So it is actually quite useful for, like in the hundreds, mid hundreds, it's quite usable. If you're using brushed motors, you probably won't be using my wheels, and so therefore this might be really vague. But anyway, whatever. We do have all these question marks everywhere, and the point of them is to help out with some of this information. So now if we were to reduce this from 80 to 37, now you'll find that that has made no impact whatsoever, because this is real time and it's reading this information back off of the Arduino. So you need to write those settings, but you need to wait. You can tell if it's worked because the serial light will start flashing, which you can't see. This little flashlight, so it'll stop and then start flashing again if it was successful. So in theory, we can now increase this only to 36/37. So that's all the way up now. It goes all the way down to 23, I guess. 22, sure, whatever. A bit of rounding there, I guess. So therefore, that's now meant that the blaster knob only goes between there, and that has set your maximum FPS on this blaster to 107. So if we pull this now, that's all we've got. If we put this all the way back up to where it was, which is about 80%, which is pretty much where you should have it for 4S operation. And now we should have heaps of beans in the tank. Something like that. Turn that back down again, frankly. Because you don't want to listen to that, do you? Okay, we've now got the rev down time modifier. What that is that affects how fast the motor spin down. On a brushed motor, I believe I've got this disabled, so it will just coast down, but on a brushless motor we actually have to control the rate of descent, or slow down if you like. Obviously if it's a higher number / percent, it's going to take longer to slow down. If it's a lower number, it's going to slow down faster. Now, why would you want anything other than as fast as possible? The reason for that is that the faster you slow down, the more heat the motor will generate, which is a bad thing if you've 3D printed stuff out of PLA or anything, because then it might get really hot and soft and mushy. And this is what I think a lot of people struggle with when they don't use my code and stuff and they just do their own thing, and even using my cages, and people come back saying this, that, and the next thing failed. I'm like, yeah, it looks like to me it actually got too hot. And this is actually quite important when we come to multiple stages, which is the next screen. Everything to do with multiple stages is relative to the first stage. So setting this to 50% will actually mean that the last stage, assuming that the last stage is a much higher RPM, will really super break the last stage and then it'll be getting real hot. So I would suggest you probably run that at 100% or more. So that's what this is like now at 150%. And if we whack that down to 50%, yeah, there's a significant difference. Since I normally play under 130 FPS, I normally run it fairly low on like 50%. But that's just me. Over here we have a high-low setting. Now, well, the low mode setting. And this sets the speed for the low mode. Now, what is that for? That's actually normally how I run this blaster. If we go and change that, turn off Jangular mode. And we write that to it. I normally have this problem where I'm shooting indoors and I engage in bogeys, if you like, at very close ranges and very long ranges, and I want to be able to swap between high and low FPS all the time, because I don't want to shoot someone in the face at high FPS. So that's normally what I use the rev trigger for. So I'll have to turn this back up again. Okay, so now we have changed that mode over. So now this doesn't rev anymore. It seemingly does nothing. I pull the trigger, it's going to shoot high FPS. Now if I pull the trigger, it's going to shoot low FPS. So that's how I can engage with close and far away people quickly, or close quarters combat. I actually normally run this the other way around. I would actually normally run this default low and pull the trigger for turbo mode, but that's what that is. So this setting here, low mode, that defines how slow it goes in the slowest speed, or the low mode. High mode is still defined by your knob, which of course doesn't work now because I haven't plugged it in. Yep, so there you go. You can still adjust that. But this knob has no relevance to this knob here, other than the fact that to prevent cheating, this always has to be lower than this. So if we put this all the way up to 80 and then we start reducing this, it also reduces the minimum, because I didn't want people to use this as a way of, oh look, it's under the chrono value, but if we put it in low mode, all of a sudden it's going higher. Basically do the inverse. Okay, we then have this setting down here, which is extended revving. This is really for stage 2, where you're not actually controlling the pusher through the Arduino. So potentially you could be firing after you've removed your trigger, but the last shot hasn't fired through the wheels yet, which is definitely how it can work. But the motors are slowing down because you've let go of the trigger, and then the last shot might just go or might go I'm stuck in the wheels. So you can extend the revving for X duration to ensure that you have actually pushed all the darts through the flywheels before they slow down. You then have multiple motors, multiple stages. This takes up to 4 stages. Yes, 4, not 3 for the Dominator. Why not do 4? Which I can only talk about because I don't have a working Dominator. If you'd love to join my Patreon, that would be really helpful. You pretty much need to enable all of the stages that you're going to use. Then you can do a real-time monitor. Now how this all works is it's relative to stage 1. So the stage 1 should be the lowest, and then you can build on that. Now you can, if you want, have all of them set to the same RPM, well, sorry, same throttle, or you can have them building. We'll say something like that. Well, let's just make that 200%, shall we? For interest's sake. We can write those. Okay, now you can see this is at 60% throttle, this is at 66, this is at 70, and you can see this is at 100%. And we have the FPS increasing across that. If you adjust the knob, the speed knob, that will then all work down. So the limits on RPM are still revolve around this one. So the lowest this can go is 22%, and the most it can go is 80%. Now obviously the maximum you can go is 100%, irrelevant of what you think you're going to do or whatever, right? So you'll see that as I adjust these ones, the last one's stuck on 100% because it can't go any higher than that. Now that means if you can potentially have them all stuck at 100% as you get to a certain point, which is 48%. If you don't want the situation where it gets to 100% and you can still continue increasing the knob, and then they'll all end up kind of out, then just set the maximum for your knob over here, set the maximum to 48, and then it won't be able to extend beyond that. I haven't imposed that by default because I actually think there might be good reason why you'd want it to continue going up. You know, if you really want that super power shot, why don't we just run them all at the highest possible speed? But in low mode or whatever, you want them lower. Now this does all come back to the basic settings. So if we increase the S rating or the kV ratings, it's going to affect it. So let's be crazy and let's do a 6000 kV motor in the center, which of course you wouldn't do. This accounts for people that want to run different kV motors in the different stages, which I think will actually be quite a large number of people. Okay, so now we've got the same throttle position, but this one's now doing 47,000 RPM and it's doing 309 FPS. Which of course this would be craziness. You wouldn't run high, low, high, low, low, high, but you know, this is just what we can do. If we set that to 5S, we will find that that has got now a crazy high. I'm not suggesting you can actually achieve that, but that's theoretically what we could get. But we shall move on, shall we? Pusher is going to take quite a lot of time to talk about. So pretty much at this point we've got disabled or default. Default is pusher like this. RS is the same. Basically it needs to have a return switch. So the RS doesn't actually look like this. It works on a completely better mechanism, but it fundamentally, from an Arduino point of view, is the same. It has a pusher and a breakpoint. So you have the rev delay. The rev delay is the time it takes for the motors to spin up before you want to start shooting them. So you need to set a delay. Obviously, shorter the better, and greater the worse. But, obviously if you're trying to spin up to 50, 60,000 RPM, you'll probably need more time than if you're only trying to spin up to 6 RPM. So you can change that. And we then have shots per burst. I mean, that's pretty obvious. So hopefully that'll work. Yep, don't know why you'd want 5. But anyway, you can do 2 or more. I like 2. Okay, we now have the rate of fire settings. So this allows you to change the rate of fire based on the different fire modes, single shot, burst or auto. It's then modified by the modifier or the knob, basically, so you can increase and decrease the rate of fire if you've got a knob, which I don't. This is currently showing 0, so that must be a bug. Better fix that. So yeah, so this is with it set to the default value. Oh yeah, duh. Pull trigger. Okay, now I haven't actually mentioned this yet, but obviously we are real-time monitoring that. If we now set that all the way down to 10 and write that, it'll be slower. Which it is slower. Now you're going to ask me, it did in the end end up being half the speed, but it got progressively slower. Why is that? Well, that's pretty much because of the next settings. So one of the real big problems we have with rate of fire is that the trigger delay, when you pull the trigger and how long it takes to start pushing, is tied to the overall rate of fire, and that is annoying. What you want is you want to be able to push the first shot out as soon as possible, and then the rest can meander out at your rate of fire. So normally you have no ability to adjust the first shot delay and the subsequent delays, if you like, or rate of fire. Whereas this we actually do. So that's what these settings are here. So this is the pre-shot boost. So even though we had set it to 10, the very first shot from standstill is going to receive 55%, which is much higher than the 20 it was, and for a duration of 60 milliseconds. So if we just put that down to the 10, which makes it the same, and we try that again, you might have quite a different situation. So there you go. So now you end up with them all sort of the same speed. Now see, this goes to show the very first shot is slower because it has to start from 0 RPM. The rest of them, it just continues on. So that's what this does. So that's pretty important. That enables us to adjust the first shot delay independently of the subsequent shots. Now obviously you wouldn't have it like I had it at this at 55 and then that at 10, because this is too high and it enabled them to sort of run on. But that was an example of it. 60, both these durations seem to be about right for at least this blaster, irrelevant of what battery you use. So we'll put those back, and now we'll talk about pre-braking, which is pretty much the inverse of this. So let's hope it's back. Okay. Now, the reason why the first one was so much slower is because this was turned much further around, so it had to travel the distance before it started pushing it, which is why The first one was quite bad. On that, really to tune this, really if it's only just pushing it forward, it will be the ideal system. So it doesn't have a delay, because there is still a delay, they're not actually touching. The other thing to consider is that when the mistake I made once was to tune this just like I am on the desk, and then roll out to a battle, and it was not that great because I'm not pushing any darts, which is obviously going to slow this down, so it helps to actually have a little bit more. And of course if you had the ROF knob, then you don't have to be that specific. The pre-brake is basically the opposite to the first shot boost. If we disable this and try it, we'll see what happens. Okay, it's now disabled. And you'll see that it didn't stop anywhere near where it was supposed to. It's now like fully half engaged. And that has just wrecked it now. Get a great first shot ROF, because of the way it works is it's not actually at the pusher at all. It's just going to start from where it is and then time how long it takes to hit the brake, which since it's now not even at the brake and halfway through, will be a relatively short period of time. But this is of course not at all what you want. So the pre-braking is it's really hard to explain. Basically, the second to last shot, when the second to last shot hits the brake, it then starts timing that time, which is 70 milliseconds. And so that means that on the way back, before it's hit the brake, it will start braking the motor before the brake is engaged, which enables us to run a much higher overall ROF because we're actually pre-braking it. So like we showed you before, this is, now that's just rubbish. So there's no way without the pre-brake enabled could we run an ROF that high. So we might have, I don't know, let's try writing that. So even that is too fast. And obviously this is now too high to work with this. About that. So that means we've actually now got an ROF of 7.4 is as fast as it can actually brake without that enabled. So that's not actually very good, is it? No. So we really need to use the pre-brake. Makes a huge difference if we enable the pre-brake. Where it can now happily handle around 11, between 10 to 12. Yeah, so definitely need the pre-brake. Makes a huge difference. But we'll move on from that. Interestingly enough, this only holds 22, I think, rounds, so you can use it for the whole magazine. Let's turn that back down to a useful number. Triggers. Okay, we have 3 triggers. You don't have to use 3 triggers. The Swordfish and the Dominator. Ugh, you're right. Dominator, get it right. Can support up to 3 triggers, and I would definitely do 3 triggers because having single or burst on there and auto on the back is just awesome. Which means you don't have to stuff around trying to flick switches or do whatever. You just like semi all the way back, auto. Yeah. So the triggers are basically the same except for the rev trigger. So you have different options, which is disabled, which means it's defined by another trigger. You have rev, so you can use this as a rev trigger and this as a fire trigger if you want, which works fairly well. I know that one of the worker Swordfish suggests you could do that with their pusher, but that doesn't work because if you pull the trigger too fast, then it's shooting before the wheels are spun up, but it doesn't actually work. It's a nice theory. You've got the HighLow Mode, which is allowing this to adjust the speed of the the motors. You got single shot, burst shot, auto shot, and you have count based on the selector switch, which is obviously the selector switch which we've got over here. So that's what I have set this up as, I think. Oh yeah, duh. Sorry. The auxiliary trigger, the front one, is set up to do that. So how many shots it fires is based on the selector switch, and the normal trigger is set to auto. We have a reset ammo counter, which I don't think is going to get implemented anytime soon, and we have the inverse of that. So one is by default being high, pull the trigger for low. The other is by default low, pulling trigger for high, which is actually how I use it. You do have additional modes in this one, which basically turns the rev trigger into a toggle. So the rev trigger will toggle whatever other trigger, auxiliary or not, into toggling between its cycle modes. So why don't we try that? Okay, so what is it in now? Single, burst, auto. Nice. And we can try that with just single and auto. So now we should be cycling between single shot, or semi, and full auto. Which we are. Cool. Okay, we have the knobs, RPM knob, ROF modifier, which you can read back. Obviously the ROF knob is not enabled, so I can't read that one back. We do have select fire. We've got a bunch of options for that. Basically, you can disable it. You've got a 3-position switch, which is actually like this one here. You've got inverted. That basically just means it moves the opposite direction. You have the rotary switch. Sorry, this is like, well, this is a 2-position switch, but there's a 3-position slider like this, like the regulator uses. There's a rotary switch, which is like this, which is when you turn, and it's not like a pop that goes forever. It's only got the 3 stages within, I think, like 30 degrees or something. So it's really useful for just going chick, 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 chick. However, it's quite large, although it looks way worse in the picture than it really is. Then you have got a 2-position switch like this, which will switch between either single or auto, or single or burst and auto. And if you want to invert that, you can just change the wiring, which is pretty much just move the white wire, in this case, from one side to the other, or just turn it over, of course. And this is a bit clearer in the wiring. We've got LEDs. Yeah, I think you've seen the LED so far. Currently disabled. Can enable it. And set how long it flashes for. If we set it to 40, which is normally what I have, that gives it enough time to turn on and off between shots. I think it's pretty cool. Doesn't achieve anything useful except for just adding that cool factor, which for just shooting the random kids is a bit of fun. If you increase that to more than the cycle time based on the pusher, then the light will just stay on. We then have the other LEDs, which can be enabled based on the selector switch. So you have to have some kind of selector switch enabled, and then it will just turn the LEDs on and off to tell you what mode you've got the switch on, which for a 2-stage switch, I don't think that's too necessary for me. We then get into wiring, which is, this is the basic stage 1. How did we do that? There's a video you can click on there. Then there is the brushed version, which pretty much replaces the motor with a brushed motor and adds a MOSFET in there. There's multi-motors, which basically says you need to connect them up to the other, these are the ports for the other stages. You do the same. In this picture, in both pictures, I only have one speed controller and one motor. Now you have 2 motors and 2 speed controllers for brushless. And for brushed, that's a bit more of a debate. You at least theoretically can have 2 motors and 1 MOSFET, or you can have 2 MOSFETs, 1 for each motor. You could theoretically have 20 MOSFETs in 1 motor. But that is up to you. Obviously you'll need a fairly decent sized MOSFET, though people tend to go crazy bananas over how big they think they actually need MOSFETs. So you don't need to go too crazy. Stage 3 wiring, well, that gets a little bit more complicated. This is just an overview of where all the pins go to. Then there's the basic, which we've just seen before. We have the triggers, and that's where the triggers go to. We have the default pusher, which is just like an overview of the MOSFETs you can use. 2 N channels and 2 P channels. The thicker lines means that's where actually the current is being drawn from, so therefore the other ones don't need to be hugely powerful. And then I've broken it down. There's also a brake video. And here is the switch for the brake, which is this thing here. And there is the accelerator MOSFET, so that makes it go. Here is the brake MOSFETs, which makes it stop. If you don't do that, then it will just coast on forever, and you will never be able to slow it. Like, you'll pull a trigger and it'll just keep going happily and stop somewhere completely random. You absolutely have to have the braking system. Then there is the diode, which helps it from all going in your face. You've got knobs, which you have got your RPM knob and your rate of fire knob. You have select fire, so this is where you've got a 3-position slider, so it needs 2 points. The 3-position rotary and the 2-position slider. You then have LEDs. Now, depending how powerful the LED is, will depend on whether or not any of these resistors or how powerful the resistors. Also, the color has a huge effect on the size of these resistor. Now, the flash LED, which is this one here, I've been naughty and I'll see if I blow up in my face. I haven't run a resistor at all, which means I'm overvolting that, and it's made it significantly brighter. However, it's on for such a short period of time, I don't think it's actually going to die from too much heat, or the fact it's going to shorten the life will have little realistic impact, and I can always replace it. But they could have a negative impact on the Arduino, but I haven't done that. But I would definitely recommend for the single burst and auto, you should definitely run some kind of resistor, because they'll be staying on, and also they would be ridiculously bright. They would be like, so don't do that. Over here we have parts. Now if we click on that, it's going to open a website and take us to the parts list for all of this, which it did, and the links. You then have parts, which will take you to pretty much my profile for 3D printed parts, which hopefully you will use to make this. There should be cages somewhere, probably at the beginning. Yeah. You then have ESCs. Now, a bit of a blah 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 about ESCs. You can run whatever ESCs you want. However, I'm only ever going to recommend, well, not ever, I'm currently recommending BL Heli 32. It's important that people know that there is a difference between BL Heli, BL Heli BL Heli S and BL Heli 32. And I recommend these specific ones because these are the only ones that we've tested that have a 0 trigger delay. It doesn't mean that they're the only ones that have a 0 trigger delay, but once you find one, you're not going to continue on looking for more of them. Other ones had a delay, and older versions of BL Heli had different delays. I've actually done a whole bunch of videos on that. You can download the application here because you have to still use their application to flash it. There's no reason to rewrite their application, it's good. and then a thing about licenses, which basically means that it's for personal use. You can't sell any blaster with it in without a small fee, which is basically to help me stay afloat making all this stuff for you guys. But for personal use for your own blaster, you can use it for free. So that's really it. It will enable everyone to have actually competitive flywheel blasters. The stuff that comes from Worker or whatever with their auto pusher, it's not competitive. It's too slow because you can't adjust the spin up and you can't pre-brake, and you have to pull the rev trigger before you push the normal trigger, so it's just not competitive. And of course this is brushless spin up, so this is just awesomeness. So hopefully you will use all of this stuff and you will make some really awesome blasters to challenge everyone with it. I certainly enjoy turning up and giving people a really good thrashing with something like this. If you've managed to make it this long, I must deserve a like. If you could become a patron, that'd be great. This should be simple, but it's not. It's cost of blowing up heaps of stuff. I'm still blowing up lots of stuff, particularly lipos, but that's generally my own fault. And I'm obviously restricted to how fast we can do the next iteration based on buying parts and bits and bobs. Subscribe if you like, join the Facebook, and everything else. If this application differs from what I've said, obviously use what the application says, because I can't update the video, but I can update the application. I don't know if I said that correctly. Anyway, I've obviously been talking for too long. Alright guys, see you on the next one. Soup.